All right, everybody, let's start with solving equations. This should be a review for most students. This is actually an algebra concept, and we're going to do several review sessions to make sure that everybody's on board and where they should be, and then we will move from there. So, solving equations. Just some examples. Hopefully, all of this makes sense and you can do it on your own. If you want, at any point, whenever you're watching my videos, you can always push, push pause and try to work it yourself. Or if I'm going too fast, you can rewind and play it again. That's the beauty of watching videos for this math stuff. So feel free to do any of that as we go along. So my first example is 2 minus 3 times x plus 4 plus 5 times x minus 1 equals 4 times 2x plus 3. And it is important that as you write these problems down, you pay special attention to those things that are in parentheses, and you work on that as we go because it's going to make a difference, right? So, for instance, I hope that you remember stuff like, please excuse my dear Aunt Sally, which is a mnemonic that goes for, or PEMDAS, some people call it. It's a mnemonic for how you do order of operations. So this stands for parentheses or any kind of grouping. That's your P. You do those things first. E is exponents. So you need to clear your exponents after you clear grouping symbols. And then M and D stand for multiply and divide. And I like to put an underline on those together because they are at the same level. So multiply and divide are opposite operations. And as you work through those, you look at it and you go, it doesn't matter. Multiply and divide, they're actually, I know M comes before D, but they're actually at the same level. So when you see those, you should be saying stuff like, oh, they need to multiply and divide at the same time, working left to right. And the same is true with addition and subtraction, A and S. Okay, so those are also opposite operations. If you want to undo addition, for instance, you would subtract that thing. So these two are at the same level, and they work the same way at the same time, working left and right, left to right. Okay, so hopefully you know how to clear parentheses, and that is for instance, on this one, we've got a 3 being multiplied into these parentheses. I'm going to distribute that 3 to both of those terms. So as I work through that, I see this is 2 minus 3 times x is 3x, and a negative 3, don't forget this minus sign goes with the 3, times 4 is a negative 12. So it's this negative 3 being distributed through is minus 3x minus 12. And that's actually really why one of the reasons why we have to be really careful with these parentheses that we put them there. If there's a negative out in front, that has to go to both terms. And if you don't put the negative into the 4, so in other words, if you don't multiply negative 3 times 4, if you got a positive 12 instead of a negative 12, that's going to completely mess up what we're doing here. So we want to make sure we distribute both the number and the sign. Okay, so here I've got 5 times x minus 1. I'm going to do the same thing. I'm going to distribute. So plus 5x. 5 times negative 1 is minus 5. And last but not least, on this third set of parentheses, I've got a positive 4 being multiplied in, and it's going to be 4 times 2x is 8x, and 4 times 3 is plus 12. Okay, so hopefully you remember how to distribute, you remember your PEMDAS, and now I'm just going to try to clean things up, and eventually the plan is to get the x by itself, because when they say solve equations, they usually say something like solve for x. Sorry, I didn't give those directions earlier. So they usually say something like that, and that lets us know, hey, I'm trying to get the x by itself. So that's where I'm headed with this thing. Okay, so keep on going. I'm going to look at this guy and I'm going to say, okay, on this left-hand side, I've got a minus 3x and I've got a positive 5x. If you're not sure, that's what we call like terms, and we should be able to combine those things. I also have just constants, right? 2, a minus 12, and a minus 5. And those are like terms because they don't have any x's. They're just whole numbers, basically, or integers. So I should be able to combine those as well. So let's do this. X's first. So I've got minus 3x plus 5x. Do your sign number arithmetic. That's a positive 2x. And then I've got 2 minus 12, and again, I'm doing this left to right, okay? So 2 minus 12 is a negative 10, and a negative 10 minus 5 is a negative 15. Okay, and the right-hand side, it's just going to stay the same. So he's just along for the ride. That's what I call him. He's just hitching a ride, not going anywhere. Okay, so now comes a little bit more algebraic type stuff where we're like, hey, how do I get one thing on the other side or whatever? Just for the purposes of moving the x's to the left-hand side, I'm going to subtract 8x here. But know that as we work through our semester together, it's very possible I'll move things to the right-hand side and the x's to the right-hand side. And the reason why is because as I do this, sure, 8x minus 8x, that's a 0. That's very nice there. It goes away. But remember, whatever I do to one side of the equation, I have to do to the other side of the equation. So I also have to subtract 8x from the left. I did it on the right-hand side. Here's my equal sign, right? So whatever I do on the right, I have to also do on the left. So as I look at that, I say, oh, okay, the 8x's will go away. That's cool. But whenever I do this subtraction, 2x minus 6x, I'm sorry, 2x minus 8x, that's negative 6x. And I know I'm going to get a negative whenever I subtracted that 8 off. So that's why I said, ooh, maybe we'll want to move the x's to the right-hand side, because if I don't have to, I don't want to deal with negative x's if I don't have to. Okay, so that's a 0. I'm going to pull down the plus 12. Okay, it just comes along for the ride. He's just coming down. Okay, so now I've got all my x's on the left-hand side. If you want to, you can ignore this 0. You'll find I do this a lot. I call it my finger covering technique. So we don't care about that guy. He's gone, so we can just get rid of him. Now I want to still get this 6x by itself. I see I'm subtracting 15, so to get rid of that, I add 15. But again, here I am with this equal sign. Whatever I do on the left-hand side of him, I have to do on the right-hand side. So if I'm adding 15 on the left, I have to add 15 on the right. Okay, this part is nice. It goes away. Okay, that's going to be a 0. And what I'm going to get here is negative 6x plus 0, but I can ignore that, right? Equals 0. I'm going to ignore that. And then I've got plus 12 plus 15, and that looks like 27 to me. All right. So now last step, I've got the x term by itself, but I want the x completely by himself. So again, in your process, I'm multiplying by negative 6. I would like to get rid of that. So I'm going to ask you, what's the opposite of opposite operation of multiplication? And I hear in my head you say, divide by negative 6, Dr. Webster. So that's exactly right. If I'm multiplying by negative 6, I can get rid of it by dividing by negative 6. Those will go away, and the x will come out. Negative 6 divided by negative 6 is just a 1, right? So I've got 1x now, okay? But again, we've got this equal sign. So I look here and I go, hey, on the left-hand side, I divided by negative 6. So I also need to do that on the right-hand side. I need to divide by negative 6. So as I scoot this up just a tiny bit more, I see, hey, the left-hand side is going to be x. This is 27 over negative 6. But I look and I say, oh, I can reduce that just a tiny bit. They're both divisible by 3. So this is 9 over 2. And it is negative because the denominator is negative. And you can put that negative sign on the top, on the bottom, out in front. It doesn't matter. If there's only one negative sign, then the whole entire thing is negative. All right, so I have x equals -9/2. If you would like to, you can always go back up here to the very original, and where you see x, you can plug in -9/2, and that should give you a true statement. True, by that I mean the left-hand side will equal the right-hand side whenever you finish plugging in that -9/2. For the purposes of saving video time, I am not going to plug that in, but I challenge you, if you're not sure, go ahead and do it. All right, let's try a couple of other examples. One of the things that you will often see happening in this class in particular is you will start with a formula. Okay, so the formula might be something like A equals PRT, which is a formula that we use for calculating. Um, I'm sorry. That is not the correct formula. Let me try again. Uh, uh, I'm sorry. I equals PRT. There we go. Okay, so sometimes I make mistakes too. It's okay. I equals PRT. So you might have a formula and you'll be like, oh, solve this for the T. This formula is used for finding interest when you know the principal, the rate, and the time that your investment is left in. So we can find that interest. So maybe I want to find out, oh, if I know I have $500 in interest or something like that, how long? So I want to solve for T. So in that case, you're going to have to get used to dealing with several variables. The last example was only an X. Now I have 1, 2, 3, 4 variables. Okay, but the process is still the same. I want the T by itself. What's happening to the T? Well, it's being multiplied by a P and it's being multiplied by an R. Okay, so as I look at it, I go, what's the opposite of multiplication? And hopefully everybody can tell me the opposite operation for the opposite of multiplication is division, right? So, okay, I need to divide, and I can do this at the same time. I can divide by both the P and the R at the same time. So as I go to divide that guy, okay, now I did that on the right-hand side. I need to also do that on the left-hand side. So over here on the left, I've got I over P R equals, and on the right, the P divided by the P is a 1, and the R divided by the R is a 1, so I just get a T. So if my directions had said, solve for T, okay, then that is how I would have done it. Okay, so that's exactly what's going on here. Sometimes we're going to have formulas that have multiple variables. Let's try a different one. Okay. At some point, you might be asked to deal with area of perimeter. I'm just having a hard time today. Okay. Perimeter of a rectangle. So the perimeter of a rectangle is equal to 2L plus 2W. That's a formula. And probably you would be given that formula, but if not, you would just look at it and go, okay, I can figure that out. The perimeter is the distance around a rectangle. These are the lengths. These are the widths. If I wanted the total area or total distance around, I would add W plus L plus W plus L. And that's where the 2L plus 2W comes from, right? Okay, so you'd be given this formula or you would find this formula and it might say something like solve for W. Okay, so you're going to come back around and you're going to say, oh, okay, no problem. I see that the W is over here and I want that to stay by itself. And I also see, hey, we're adding 2L to that. So if P equals 2L plus 2W, then I want to solve for the W. I'm going to get rid of this 2L. It's being added. So again, what's the opposite operation? And again, in my head, I hear you saying subtract. Okay, addition and subtraction are opposite operations. So when I subtract that, these are going to go away because 2L minus 2L minus 2L is a 0, right? And that's just going to leave the W over here by itself. And that's fine and dandy, but on this other side, I also have to do that, right? Because remember, here's your equal sign. So if you do it to the right, you have to do it to the left. So on the other side, I'm going to have P minus 2L equals 2W. Okay, so over here, P minus 2L, those are not like terms, right? One has a P, one has an L. I can't do anything with those, so I'm just going to hold them along, carry them along for the ride. Okay, and so last but not least, I say, well, the 2W is by itself, but the W is not by itself. So it's being multiplied by 2. To get rid of that, I can divide by 2. And whatever I do to the left side or the right side, I need to do the left side. So I'm going to divide that by 2. Okay, this is going to sit here for a second, but we know the 2 divided by the 2 goes away. That's a 1. And so I have at this point, and let me rearrange this just slightly so that the W is on the left. W equals P minus 2L over 2. All right. For my purposes, I'm happy with that. I can leave that alone. But some people want to clean it up even more. So that's what we call it when we're like, oh, I see this other thing could happen. Okay, so if you see that the 2 and this 2 could go together, that's fine. But you have to be a little bit careful because you have to separate that. Okay, each of these is getting the denominator. So if you want to separate this, it's P over 2 minus 2L over 2. Okay, they both get the denominator. Okay, and so now whenever I look at this, I do see, hey, that 2 over 2, that'll reduce out. That's a 1. Okay, but the 2 stays underneath the P over here, right? It doesn't go anywhere. So this is P over 2 minus L. So if you want to clean this up a little bit more and you see, oh, those 2's will go away, that's fine. You can do it. 2 over 2 is a 1 in front of that L, but be careful because you can't get rid of the 2 from underneath the P here. Okay, so that's where you have to watch out. So again, this is a formula. It's got 3 different variables in it, and we can certainly do this. Be careful with it. All right. I'm going to let you work on one. So what I would like is for you to pause the video once you see what the problem is, what the example is, and go ahead and do some work on this thing. And then, start the video again. And real quickly, I'll run through it for you. So the problem says solve for H. And the formula that you're going to have is S equals 2LW plus 2LH plus 2WH. Okay, so solve for H here. If you're not sure looking at this, you see there are 2 terms with H's in it. So this is where you need to dust off your factoring if you haven't done that. So go ahead and take a look at that and push pause if you need to, and then come back. I hope you push pause so that you can work on it. Okay. So, hoping that you've already pushed pause and now you're back and you remember how to do this, because there are 2 terms with H's in them here, we're going to factor. And we see there's an H in each of those, so we will factor it out. Okay, we'll put it out in front. So whenever I pull out the H out of this term, what's left is a 2L. And when I pull out the H out of this term, what's left is a 2W. So when you finish that process, it's like reverse distribution, okay? You should be able to look at this and say, if I were to multiply this guy back through, would I get what I started with? So H times 2L, yep, I'd get that. And H times 2W, yep, I'd get that. So you can check yourself by distributing it back through and making sure you did it, okay? So factoring, it's like I divided out the H and I put it out in front. It's still there. It's not gone yet, okay? Well, it's not going to go. Actually, the other stuff is going to go. But I divided out the H and put it out in front because I want to separate it out from all this stuff that's being added and multiplied, okay? So now the problem says solve for H. I'm going to first get rid of this term. Okay, it's being added, so I'm going to subtract it, minus 2LW, and that will give me S minus 2LW, because I moved that guy over, equals H times 2L plus 2W. Okay, now looking at it like that, I say, oh, that's the H guy that I want to get by himself, right? He's being multiplied. That's exactly where I wanted him. So to get rid of all this other stuff, I'm going to divide by all that other stuff. It's important to realize that these things in parentheses are attached to each other. This plus sign inside of parentheses means this is one big thing, okay? It's got two terms in it, but it's one big guy. So whenever I go to divide him, this is not like divide by 2, divide by L. It's divide by 2L plus 2W. You got to divide by the whole thing. Now, the nice part is over here on the right-hand side, those are both going to just go away because anything over itself is just a 1. But over here on the left-hand side, it's all going to be together, and there's not going to be something that just easily cancels like on the other one or reduces out. Okay, so what I would say is I'm okay with this answer right here. If you want to clean that up even more, if you're trying to do something, you've got to be super duper duper careful because you would have to separate the denominator to both of those terms on the numerator. So like this would be S over 2L plus 2W minus 2LW over 2L plus 2W. And then you would have to factor out this 2 out of the denominator and then get rid of it out of that second fraction. I don't do those things because I don't feel like it's worth I don't think I get enough value out of doing that. Okay. I don't feel like it's worth the effort. Okay. So some things I will clean up because I feel like they're relatively easy to do. And some things I'm like, yeah, that's just a lot of extra work and I'm not getting much good out of it. Okay. So this is one of those things that for me, I'm just going to leave it alone. So my answer is H equals S minus 2LW all over 2L plus 2W. Okay, so there you go. All right, let us do a little bit of word problem type stuff because you're probably going to see some of these in your homework. So let me read one out. I've got, um, you're going to buy a TV and the salesman tells you there's a $65 delivery fee. So I'm only going to write the important parts that what I think is important here. You can do other stuff if you would like to, but I'm just going to do that. And they tell you that there is 7% tax that they will add on top. Okay. And you know that the total, they're telling you that the total is going to be 1,000 $668.93. And you say, "Hey, hang on a minute. I wanna make sure that's right. Let me find out what the price of the TV is." Okay? So let me make sure they're actually charging me the correct amount for that TV. Okay? So whenever we're doing something like this, we're gonna have to set this up in an equation, and we're going to have to get a variable in there. So I'm going to let X be the price of the TV. That's my plan. Let X be the price of the TV. So let's go ahead and talk about this. How is this going to work? The total price of this TV is going to be whatever the price of the TV is, plus I need to put on the $65 delivery fee, right? Plus I need to do the tax, okay? And the tax is on the price of the TV. So it's 7% of the price of the TV. But we don't write 7% whenever we write things in equations, right? Instead, we convert this to a decimal. So if you're not sure about that, just kind of go off to the side somewhere. I'm going to put it right here. 7%. What we do with that is we move the decimal to the left 2 spots, and we're going to get 0.07. Okay, so that's my percentage. So it's 0.07 times the price of the TV. Okay, so I'm using parentheses. You can do it however you want. Equals the total price. That's what they told me it's going to cost to get this TV to my house. I'm just a little bit leery and want to make sure that they actually have the right price on there. Okay. So, how can I go about doing this? The first thing I see is, oh, look, I've got like terms. I've got an X and a 0.07x. Okay. So I need to combine those. The second thing I see is, hey, there's this plus 65 here, and I want to subtract that. I want it to go away. And if I do that, I can subtract it from both sides of the equation. In fact, I must subtract it from both sides of the equation. And then it'll just be gone. And this number on the right will be something. We'll see what it is. If you have problems with your equal signs, I recommend doing something like this that keeps them separate, the sides separated for you so that you're not confused by what's on what side. Okay, so over here, this goes away. This is a 0. 65 minus 65 is 0. X plus 1 point or x plus 0.07 is going to be 1.07x. All right. If you're not sure, punch that on your calculator. And this guy, whenever I subtract it, is going to be $1,603, right? And 93 cents. So you can do that math right here. 1,603 and 93. Now, here's the thing about something like this. I am not doing that math in my head, and I'm not going to take the time to punch that out on a calculator. So from the begin or to punch it out by hand. So I'm going to use my calculator, and hopefully from the beginning we see, oh, we need a calculator here. So please make sure you get one. We will be doing some graphing type stuff, so I recommend either an 83 or an 84, and I think those are the most relevant, most used in Texas in particular, because it's a Texas Instruments. Okay, so here I want the x by itself. I see I'm multiplying by 1.07, so I'm going to divide by 1.07. Okay. And whenever I go to do this, I say, hey, over here, this goes away. And what I get left with is x equals, but here's where I'm going to use my calculator, 1603.93 divide by 1.07, and I get 14.99. Okay. So hopefully going backwards here, so to speak, to get to the price of the TV. Hopefully that $14.99 is what I was expecting. That's what they were supposed to be selling it to me for. So you can actually, do a little bit math and figure it out. Okay, so that's the price of the TV. Now, they didn't ask me, but if I wanted to, I could also very quickly now figure out how much tax I'm paying, right? Because now I know the price. Let me do this right here. Now I know the price is $14.99, and I know the tax was 0.07 times the price of the thing. So that was $14.99. Okay, so I can use this little bit right here to figure out the tax. I already put away my calculator. So $14.99 times 0.07. Oops, that's not right. $14.99 times 0.07. Be careful with it. $104.93. So the taxes you were paying is $104.93. So what you should be able to do now, if you wanted to, is you should be able to add the price of the TV plus the price of the tax plus the $65 delivery fee, and you should come out with $1668.93. Okay, so that's another check for you if you would like to. Hey, let me make sure I've got everything correct. Yep, you sure do. All right, that's good. Okay, I think I have one more example on this, and then I'll call this a video. For this section, it is an example about bike computers. So apparently, you own a company that's working to create computers for bikes, and here's what you know. You have fixed costs of $48,000, and you have variable costs. And what they mean by variable costs is it varies. Okay. This one changes depending on how many computers you make. So $12.40 per computer. So what do we mean here? The fixed cost is things you must pay no matter what. For instance, you must pay for the rent on the building, okay? If you're in manufacturing. You must pay other things, taxes and stuff like that that you just know they're coming, okay? $48,000. But the thing that changes is the $12.40 depending on how many computers you make. That's called variable costs. Okay, so that's the difference between those. So, in other words, this is probably things like the material it takes to make the computer, the man hours of labor that it takes to make the computer. Okay, things like that. So, these are your fixed costs, and you know that you're selling them at $17.40 per computer. Okay. So again, that's a variable thing, but that's going to be revenue because I'm selling. So that's money into my pocket, right? So this is money in. So first off, I have to do some things in kind of a business mathy kind of way, such as can I create a function for cost function? Well, yeah, I can. I know that I'm going to have to pay the $48,000. So C of X equals cost of X. X is going to be the number of computers. Okay. So my cost for creating however many computers is going to be the 48,000 because I got to pay that no matter what, plus the $12.40 per computer per I'm multiplying, right? Okay, so 1240 per X. Okay, that's my cost. What about my revenue? Revenue is money in. So that's going to be based on what I'm selling. So that's going to be, hey, can you create a revenue function? Well, sure I can. Okay, R of X. Okay, so I'm going to take the price times the number sold. All right, does that make sense? Okay, and in this case, we're going to assume that my cost or my number that I'm producing is the number that I'm selling. Okay, so that'll be my X as well. So for a revenue function, I'm going to have something like this. Revenue is the price, 1740 per computer. Okay, number sold. So there you go. So I can come up with pretty quickly whenever they tell me stuff like this. I can come up with both a cost and a revenue function. Okay, so that's one of the kind of business math topics that we need to be able to do. Okay. But that's not the point of this problem. So that's just kind of a little background. Hopefully, you've seen this kind of stuff whenever you were like in the algebra class or something like that. Okay. The point of this problem is actually they want me to find the break even point. That's what the directions say. Okay. And that's what we need to focus on here. Okay. So, what does that mean? What does a break even point mean? It is actually where I create a certain number of computers and my costs of making them is equal to the revenue that I'm bringing in. So, in other words, I'm not making profit, but at least I'm not losing money. Okay. So, we find this by saying C of X equals R of X. That's that's our process for a break-even point. So C of X equals R of X. I've got both of those functions. So the question asks me to find a break-even point or the break-even point. And so now I'm going to do that. Okay, so let's see what we got. We have a cost function. Let me scoot. Sorry, I need more space. Okay, I've got a cost function, and that was 48,000 plus 1240x is equal to the revenue function, and that was 1740x. Okay, so I get those two things right there. The cost equals the revenue, and I've got it just fine. Okay. Now I see, oh, I'm trying to find the break even point. Well, that's a matter of finding out how many computers do I need to produce and sell in order to break even, not get profit, but not have losses. Okay. So that means solve for X, right? That's what I'm in the back of Dr. Webster's brain. She hears solve for X. And so I will. Okay. All right. At this point, I'm going to implement the idea that I want to keep my numbers positive if at all possible. I see that the bigger coefficient is on the right, so I'm going to subtract the 1240x from the left-hand side and move it to the right-hand side. And when I do that, the 1240x on the left is going to go away, which is great. They just reduces right out, which I like. But on the right-hand side, I've got 1740 minus 1240. That's going to be a 5x, right? Okay. Now, you can switch sides at any point that you want to. So if you would like to, if you need to do this step, you can just swap these because that's what I'm about to do. Okay, I'm going to move it so that the X is on the left-hand side, just because that's like a mathematical convention. We like to have the X on the left-hand side. So I'm going to do 48,000 divide by 5. And I'm going to get, oh, why did I do divide by 5? Because the X is multiplied by 5. So to get rid of that, I'm going to divide by 5. Okay, so I'm going to get X equals 9,600. 9,600. All right, cool beans. All right, there we go. So that's what this is looking like. And those are the types of problems you're going to see on your homework. If you have questions about how to solve for a particular variable, let me know. But again, I'm really hopeful that this is review for everybody. All right, so that's it. Have a great day. Let me know if you have questions.